can always go back to the YouTube and refresh yourself to understand the steps which would have been taken through by the facilitators. So ladies and gentlemen, we beg that today, please, can we pay attention so that we can move, so that we can be able to achieve our objective of the training. And if you have missed, we beg that you go to the YouTube and review the training again, and you can follow. If you have maybe a serious specific question, you can get in touch with the facilitators after you viewed the training on YouTube. So ladies and gentlemen, thank you. Let me introduce our facilitators who are taking you through the second day of the training. Dr. Helen Namaweje, the floor is yours.
Jolene, maybe just before the professor comes in, just to advise our participants that because of the high number, it would be good that we reserve the Q&A box to be only for questions and answers, questions. So please do type in questions, and then the rest of the things you can keep them in the chat box. That way it will be easy for the facilitators to follow up and provide responses. Thank you.
Thank you so much. Over to you, Helen.
Good morning, everyone. Sorry, I was muted. Before I speak, I would like to call Professor Susan to first give us a word, then I'll proceed. Thank you.
Good morning, everybody. You're welcome for the second day of our training. There are some issues that we want us to know about R. The first thing is that we sent materials afresh to everybody, and we don't expect anybody to ask for materials now. The second one is that we sent out homework, which included installing packages and loading them. We are not going to go through that today. We hope that everybody has installed the packages and loaded them. We also advise you to get an updated version of R Studio and R. As Dr. Helen was explaining, we need an updated version of R Studio and R for us to be able to execute the commands. In case your version is lower than what we have, then you get problems of commands not working. The last thing, second last thing, is that always use Google. Always use Google. You have access to internet. So whenever you are stuck, you can just copy the error message in the console, paste it in Google, and then you will get a response immediately, because there are several people who have faced the same problem in R, and there are people who are answering those questions. So you can get a solution immediately. The last thing is that we have a support link, and that support link will be either posted in the chat, or Dr. Helen is going to show you in the material, I think material she sent, there is a support link. It is a Zoom link for only 45 minutes. We'll be supporting those who are lagging behind. So after the session, if you feel you're fresh and you can participate in the next 45 minutes after lunch, then you can log on using that support link. We are going to paste the support link in the chat so that everybody will access it. Thank you very much. I hand over to Helen.
Thank you, Professor Susan. A very good morning once again, and I welcome you for day 2 training. Like Professor Susan has communicated, I sent you some work yesterday. I'm hoping that you are able to install the packages that we are going to use for today. Yesterday we were a little bit slow, and so I want today for us to see if all the packages are installed, then we are going to try to be very fast. Can I confirm in the chat that that you successfully installed the packages? Can you type yes? I just need to get a feel of that, and then we proceed. Okay, great. Thank you so much. I'm glad that most of you were able to install all the packages. So it's going to give us a smooth flow as we're moving on today. So I'm going to share my slides, and then we continue. Okay. For this slide, Professor Susan has communicated about it. Now, what we are going to do today, given that we've got the required packages installed, now today the main thing what we want to learn about is how can we transfer our data from Excel to R? Because by the end of the day, if you're going to do analysis, you need to import your data to R and then see how do you proceed with analysis. I encourage you to get the basics such that because you need the basics before we dive into the real analysis. Unless you get this part very well, then it will make the coming trainings or the coming days very easy for us. Now let's first understand what is a data frame. As far as a data frame is concerned, you can call it a data set, or in an easy language, it's a spreadsheet. Most of us are looking at the level of expectation that we saw on the first day. Some of us have collected data. We've gone to the field, or you've conducted the survey, you've went to the field and collected data. But when you're collecting data, most of the time you put it in a spreadsheet. When you collect the data, you put it in a spreadsheet. So when you look at my slide, I gave an example that it's an example of an Excel sheet whereby somebody went to the field and collected about the weight, about the quality, about the color. I extracted this example from the data set that I sent you, which is Lab 2, Excel, and then Lab 2, the CSV. So I'm going to first share with you how the data looks like, and then we proceed. And even we need to understand the interpretation of how the data, within this particular data, what does it mean? But I'm going to try to be a little bit quick, such that we get back to R. Kindly open your data sets. We are going to go through each. I'm going to just explain the details as you have the data sets already. The data set that I sent you, which is Lab 2-data. So within that data set, it was a data set about the diamond. I picked part of this data set from R. R has got different data sets that you can use either during the for learning purposes. You can go to the Crane, and then you download the different data sets. So for learning purposes, I just picked the data set that I sent you, and I picked only the variables just to support us for learning purposes. Usually, sometimes when you're having data, it is always important to understand what the different variables mean. For example, when you look in the spreadsheet that I sent you, we've got the columns, we've got the rows. On the columns, we are having observations, and there are 100 of them. Sorry, those are the rows. Whereas on the first row, you've got the variables. For example, it has got price. And when you check in the description how they are determining price, that is the price in the US dollars. And then we have quality, we've got color, we've got the length, we've got the width, we've got the depth of the variables. So the point is that it was a data set that was drawn whereby they looked at diamonds. For example, in case this is an example of a diamond, if you're seeing my screen, whereby they took the price, they took its weight, they took the length, the X, Y, and then Z. So there were different diamonds. So in this case, our observations are diamonds, different diamonds, which there are 100 of them. But on these diamonds, on each, they were picking those characteristics, the variables that I'm talking about. So that is the data set that we are going to to use in R. So I'm going to stop sharing that, but I just wanted you to know what exact data set that we are going to use. So now, like I explained earlier about a data frame, if you find the word data frame complicated for you, just look at it in terms of a data set or your spreadsheet where your data is. I've put the different characteristics, which we already know, that the columns and the rows have to be non-empty and the rows have to be unique. Like in the data set I sent you, we've got different rows for that different diamonds. So they are unique. And then we've got the columns that have got our variables. And when the data is stored, it's stored in different ways. Sometimes when you look at that data, you see some of them, they are numeric, others are characters, or you can call it a string. Numeric is the same as like a number. It could be an integer. So if you, in case you see an integer or a whole number, those are numeric factors. Those are numerical variables. Whereas for the case of a factor, you see different strings, but we're going to dig into further to understand what a factor is in a variable. One thing that's, as you understand in your data set, for example, I've given, there are certain things you're supposed to understand the different level of measurements. What does my variable talk about? In this slide, I gave an example like gender. We know that gender, somebody can either be a female or a male. So in that particular case, those are attributes, and my variable is gender. So within the data set, we also have certain variables that are categorical in nature. For example, the quality and then the color, whereby the quality it is categorized, and then the colors are also categorized. So in case your data has got categorical variables, what do you do? How do you tell R that please look at this as a categorical, whereby we call it as a factor? Factors in R, the moment you label your variable as a factor, you're telling R that, you know what, as I'm doing the analysis, look at this variable as a factor. So more examples that I gave, for example, in case you've got a variable like party affiliation, it is also categorical in nature in the sense that it has got 3 attributes like Republican, Independent, and then Democrat. However, you can still further go and code these attributes with figures like 1, 2, and then 3, depending on how you want to analyze. You can use the values or you can use the attributes directly in the analysis, but we are going to see that. So the point is, my summary is, when you look at your data set, it's always important to understand what is taking place. For example, the different types that you have to look at as you look at each particular variable when you check in your data set, are there variables that are nominal in nature? For example, the order doesn't matter. Sometimes you've got variables whereby the order matters, okay? For example, an example you can take, it could be the level of qualification, or you can look at the days of the week. You're looking at Monday, Tuesday, there's a certain order there. Whereas where it's nominal in nature, the order doesn't matter, you can say, you can have male, female, you can look at the different categories and the order is not there. The interval and the ratio, these ones are, they are numerical in nature, they are integers. So there is a scale or numerals. For example, for a scale or for an interval, you can check and see that maybe the distance is between 30 and 40. So in that particular case, that is a scale variable. Both interval and ratio variables are scale in nature, or you can say they are numbers, integers, etc. But in your data set, you really have to understand what they mean such that you make the right analysis. Okay. It is important to understand your data set or the different level of measurements that I talked about, the nominal, the scale, and then the ordinal one. Why is it important to do that? Because by the end of the day, your data set is going to enable you to understand what kind of statistical analysis are you supposed to do and also propose the right interpretation. So there are 4 types of, in this particular case, we have the nominal, ordinal, interval, and ratio. I'm referring to them as a scale. Okay, so now what you are going to do, Now, from my particular explanation, so we are going to go to R, and given the fact that you've looked at the data set that I sent you, the lab that we are going to use, and check how do we bring in these variables within R and then move on. Remember, I talked about the R script yesterday, what it does. I'll explain more about the R markdown when we go into R session, and then we see how do we get our data into R. So now what is important right now, we are going to see how do we import data into R. Having understood our data set very well, it is always important because it will help you doing the right analysis. You can import different data sets into R, for example, the CSV files, the Excel file, the table delimited files. When they say table delimited, what should come to your mind is that it is just a format that stores data in a tabular form. For example, in a spreadsheet, because most of the time the data you see it's in a matrix form. So that is what we refer to as tab delimited files. And as we move on, I'll still put more explanation on that. And then also there are some times whereby you can get different data sets of other kinds from other programs. For example, you can use Starter, you can import from SPSS, or you can use import files from SAS. Then, okay. Yes. When you look, when you collect data within Excel, I don't know if I can share an Excel sheet. Okay, let me just explain that. Somebody was asking an Excel sheet. You know, when you're having an Excel sheet, most of the time we are used to save it as XLSX. When you get to that Excel sheet, we've got different saving styles. So you can save it as an XLSX, the normal one that we are used to, or you can save it as a CSV. That is the you have to choose the saving style. But within R, most of the commonly one used, it's either you can save it as a CSV or an XLSX. All those are just extensions. For example, like the way we saw it in R, whereby your extension was .R, depending on the name that you have. And I guess when you check the data set that I sent you yesterday, I sent you 2 files that have got the 2 types of saving styles. So that should not confuse you. Yes, the comma separated values, that is the CSV. So can you please type yes if you've got clearly what the data we are going to use is all about, understood the different variables within our data set. Great. Okay, now we are going to move to R and see how do we import data. In case you have a question, you can pose it in the Q&A. Professor Susan will be able to explain more for those who have not yet gotten on the same pace on how the different variables are, and then she'll be happy to respond. Great. Now we are moving into R, okay? We want to import our data set such that we start the analysis into R. So remember, we have to load the different packages that I sent you with a different explanation. I sent a PDF. So I'm just going to, in case you installed them already, all you do today is to load them by running the libraries. And then if you're having the R script that I sent, which is titled model1.r, it's what I want us to go through today. And in case there is a question, then I'll be happy to attempt it as I'm asking. So what I'm going to do today, since I've already installed my packages, we can work together as you are on that side. I'm going to run my libraries, which was our homework yesterday, okay? When I run, remember, I type everything in RStudio, where my R script is, and everything is being seen in the R console. The moment I see my R console and things are blue, there is no red, it implies that everything has been loaded very well, so I can proceed on. Okay, kindly also run the libraries that we are going to use. Now, we need to set a working directory. And there are different options on how you can set the working directory as you follow in the slides that I sent you. Okay, I've got a question which says that what is an attribute? Like, I'll give an example. Within the data set that I sent, there is a variable called quality, whereby we are looking at the quality of a diamond. Okay, in that particular case, quality is my variable, or it's something that I've got interest about, a factor on a diamond. Now, but when they were capturing the variable quality, there were 5 categories that they talked about. And among the categories that we had, among the categories on the quality, we had like ideal, we had good, we had fair, then very good. So in that particular case, the categories of quality are the attributes. Hope that is clear. So the different levels of a certain variable are what I'm referring to as attributes. I gave an example about gender. Gender is a variable, but gender can be categorized into 2 levels, the female and the male. The female and male, the categories are my attributes in that case. Hope that is very clear. Now, what we are going to do, there are different options on how you can import R. You can import your data in R. So we are going to first use the common ones that you can quickly learn. And then in case you get them very well, we can move on. Which one? Hmm? Okay. Okay. As we proceed, I don't want to over-repeat myself. In the homework that I sent to you, some people are still asking what is the difference between installing and then library. When you're going to run R, there are certain packages. Yesterday I mentioned that packages, these are just a collection of functionalities that are going to help you when you are doing your data analysis through the different manipulation that we are going to do. And within these packages, in case you feel they are not so much clear, even in each package, there is a document that can take you into more details on what it does, what it means, and then who was the author, because it's a community, a group of different software developers that are running it. So having gotten these packages, after installing them, it is not enough. The next step is you have to load them by using a library command. And when you type library, then in the bracket, you put in the packages that you installed, implying that after loading, when I say loading, I mean that you put the packages in the library command, because you need to load, you need to tell R, I've installed, now I've loaded, so I need to proceed. Okay. And then a question about variables. What is a variable? You know, in a simple term, I'll give an example. In case you, for example, some of us are educationists. If you're looking at maybe, let's say, factors affecting price of a certain good, okay? Those factors could be very many. You might have something like maybe the political environment. The political environment is a factor. So you can also call it as, it is because it affects the price of the commodity. So I can call it as a variable. It affects the price in the sense that when there is maybe, for example, political instability, then it implies that still my prices are going to change. So it is the one that makes what you want, your point of interest, to keep varying. So that is a variable. On the diamond data set that we are having, for example, you can see according to among the factors or the variables that we have, these are the names that you have on the top of the Excel sheet, where we have the quality, where we have the weight. Those are the variable things that keeps on changing. And when you look at what we are having there, for example, sometimes as we move on, you're going to ask yourself, I'm having all these particular variables, but which one affects the other and which one doesn't? Whereby we are looking at the difference between a dependent and an independent variable. In that particular case, for example, when I look at, because with the price, with the dependent, something that keeps on fluctuating, or which is influenced and then it keeps on changing. In case I consider price, in that case as my dependent variable, all these other things, the quality, the price, the length, the weight of a diamond, all of them affect price. But all those factors, I'm referring to them as variables, or you can call them characteristics. Hope, okay. There's a question that has come up that I show you the Excel file. Let me share that. In the teaching materials that I sent yesterday, actually I've been sending these materials over the weekend. I sent you this data set that has got lab 2. And within this particular data set, are you seeing the Excel sheet I've shared? Prof, are you seeing it? I want to confirm.
We're seeing it.
Okay, great. So this is the data set that I sent. Among within this data set, we've got weight, okay? That is my variable. But in this particular case, my weight doesn't have any attribute because it is numerical in nature. They are numbers, okay? When you move on to another variable, call it a characteristics of a diamond, because we looked at diamonds, the data set that I sent you. Another variable or a characteristics that I looked at, it's quality. But when you look at quality, it has got strings. It has got premium, fair, very good, ideal, and so on, okay? Which was being measured, which was being captured on different diamonds. So in that particular case, my quality, it's not numerical in nature. It is categorical in nature. But when we move to R, we need to command R that, you know what, my quality variable is categorical in nature. So I'll record it as a factor using a factor command. The same applies, another variable is color, which is also categorical in nature. We've got another variable, price. In this particular case, when you see price, they are integers. So it is also numerical in nature. We captured the length of a diamond, the width of a diamond, and the depth of a diamond. So this is the data set that I sent. And for learning purposes, we want to import this data set to R and see how does it look like. So it is the next step that we're going to move on. How do we import data into R? And then we do further analysis of what really we want to learn today. Any more questions? Okay, now I'm stopping to share this. Now let's move to R, since now we've seen how our data set looks like. I mentioned about the level of measurements in the sense that when you're having your data set, the first thing you're supposed to understand is that what is the meaning of each variable? My variables are weight, quality, color, etc. Is it numerical in nature? That is either scale or a ratio. Is there any order? And I call it an ordinal variable. In case there is no order, then it will be a nominal variable. So you need that particular description. I still sent you this particular part on the training material. So now let's move to R and see how do we import data to R and then do further work. Let's proceed. We are moving on to importing data. Remember the data we have got two types of data sets. We've got the CSV and then the XLXS, the extensions. Now, what we are going to first, we are going to use both of them at least a little bit fast, such that you get to know what we are supposed to do. There are various options, and I'm going to start with the easy one. Okay, now in case we want to import the one with an extension of XSLX, let's try that. What we are going to do, I'll repeat, but let's see how we can go about it. You go to File. I encourage you to have a folder on your desktop or on in your document, anywhere, such that you're able to do it very well. Option 1, so when you're importing, you go to File, then you move down, Import Dataset. Okay, so when the moment you see that from text or read are all the things that we have. I mentioned earlier that you can import other data sets either from SPSS or from SAS or from Stata. But for us, we want to do it from Excel. Okay, then you scroll down to Excel. That is, we are looking at option 1. Now, when you come here, when it brings this window, import Excel data. What I do in the file, it's asking me, I mean, what file am I going to get my data from? So you move your cursor to Browse. Under Browse, you can go to, depending on your folder. So for my case, I've got a desktop where I've got that data set. It's where I'm going. So it implies that depending on where your data is, it is where you're supposed to import it from. So on my desktop, I've got a folder, which is macro forum project, where I stored that data. So it's where I'm going to pick it from. I click on it, then I come to module 1, and I check for my data set, which is this one. I'm starting with the lab2-data.xlsx extension, the Microsoft Excel extension. I click on it, and then I click Open. The moment I do that, below there is, if you look at now clearly, now my window has been filled. I'm seeing the data set that I imported. And I've been shown that now my browser is from computer users. Then it is giving me a path that I use, and it's showing me also the data. And then after that, I go and click the box down, import. Okay, the moment I do that, then what I see in R, my data is being shown. And even when I come down here, it is showing me that we use the library readxl, and then it is also giving me that lab 2, it is using a command read_xl, okay, whereby it shows me that the path that I used. And then after, the third thing it does, it shows me to view the data, which data that I'm seeing in my RStudio in the top. And at the same time, when I check in my environment, what is it doing? Look at, when you look in your environment, it looks at the environment, it's on the right-hand side by the upper box, whereby it has environment, history, connections, tutorial. But under, if you're seeing my cache very well, it has got lab 2-data, and it is showing me within the data, there are 100 observations. Those are the 100, those are the number of the diamonds that we are considering in the data set. And then with 7 variables. The variables, you just count 1, 2, 3, 4, 5, 6, 7. The weight, quality, color, price, length, width, and depth. I want to pause and see and ask if give you just 3 minutes to ask you if you've been able to do the same with your data. Okay, wonderful. I've seen many yes, we've been able to import that data, and then some haven't. Some are saying they don't have the data. Please check under the materials that we sent, that data set is there. I sent 2 types of data set, the lab 2 data, which is saved as an Excel sheet, and the other one is saved as a CSV. So I'm going to redo the process once more, and then we proceed. Please follow closely. Okay. I'm redoing the process again. We need to import data, the data set that I sent, but now I'm only beginning with the data set that has got an extension of XLSX. It's what we are starting with, and it is very easy. What we are going to do as option 1, we look at other options such that we move on the same page. You go on to File, okay, in your RStudio, you move down to Import Dataset. When you come to Import Dataset, you go and click from Excel. Right now, I believe on your computer, you've got a folder somewhere where you stored this data, okay? You click Excel. The moment you click Excel, it is going to bring you this particular window that import Excel data. However, when you look at it closely, it needs what path, the URL that you're going to use. And then in this box, which is empty, it will give you a data preview, how your data looks like. And when you look at the code view, it is automatic. R does it for you with this particular option. It is telling you, I'm going to read the data set using the library readxl, which we have already installed. And right now, it has got null because we've not indicated the path yet. And then later, we are going to view our data set, how it looks like. Okay. Now, I go on to, I browse. I want to go in the folder where I stored my data. Okay, I continue, it's on the desktop. I stored mine on the desktop. I've got a folder on my desktop where this data is. I click that folder. Then I continue to the module. Within the module, that's where my data is. And then I click on the data set, the lab2_data.xlsx. Please don't import the one with SSV. I'm also going to show you another option in case you want to import that one. Okay, I click on it. Then I come and I click open. Okay, the moment I click open, you see, now my file stock URL, it has given me a path that I follow to get the data. It has given me a data preview, how my data looks like. When you come to the code preview, it has used the library. And now in the read_excel command, initially it was null, but after importing, it is giving me the path that I used to import the data. And then also I'm able to view. Then I click import. So in this particular case, with the view, I'm able to see my data, how it looks like. Remember, R used a read_excel command, which we are having here. And then, interestingly, R went ahead to label for me how I can pull this data using the lab2_data. In R, there is what we call an object. An object, it's like you want to name your data set. But now, since I labeled my data as lab2_data, it automatically used it as my object. However, you can change it. You can name it anything that you want. But for the starting purposes, R automatically gave us that particular name. And then inside, whatever you're seeing here, that this is the path that we follow to get where our data was. And then I've also got the view command. I'm going to give you 3 minutes and see that we get on the same page, and then we'll continue. Please walk through what I've done with the data that you have and import it in R such that we'll move on together. Hope we're on the same page. Okay. In case somebody is asking, in case you're missing the data set, which has got the extension of XLSX, please go and open the data set, which is saved as CSV with an extension of CSV. Then save again, because Excel has got different saving types. Should I show it? The saving types. Some people are still asking about the materials again. We did that already. But Professor Susan can help. So I'm asking in the chat, can I proceed? Please type continue if it is okay. Type okay. Okay. Great. Fine. So that is one option on how you can import your data in R. When your data has got an extension of XLSX, the normal Excel sheet, we are going to move on to a second option. In case you want to what most of the time, most of the Excel sheets that are imported into R are saved as CSV, the comma separated files. So now, how do we import that particular? Let us move to option 2. So in this particular case with option 2, you need to set a working directory. There are 2 options on how to do that, but it's also very easy. You can either do it manually or you can still use R to help you out. So you can go, we are looking at option 2. This time around, we are going to import the CSV lab file. After that, the moment we are successful, then we start the analysis. Okay. Option 1, kindly go to your R Studio and check where there is a word session, and you click on it. The moment you click on it, then move down, it will tell you you need to set a working directory. So under the working directory, you come and say, choose directory. Okay, you click on it. The moment you click on it, you're setting a directory in the sense that you're telling R where your data is. Where is the folder where your data is? So check again the folder where you saved your data. It is different for my computer, and it should be unique for everyone because we are using different computers. I'll still go back and then check my, okay. Now, in module 1, that is where my data set is. So the moment I reach the folder where my data set is, I stop there and I say open. Okay. Now, when you look in your console, if we are together, there's something that has popped up. That's the set WD, that is set working directory, the one that I've highlighted. And it is giving you the path that you're moving from your computer, you go to users, then to the folder where your data set that you want to import is. No? It's not part of it. Kindly follow through the steps. What I'm doing is what I need you to do. Okay? Then we are going to move together. So we've set a working directory. For those of you having the module 1.R, I guess you're seeing that path that in this one here. That is how I developed it. The set WD command, it is the one that helps you to set the working directory, and you tell R that it's within this folder that I've got my R. Okay. Now, what you can do, there are 2 procedures from there. When you're importing data that is saved as .csv, then we use the read.csv command, and then it will help us to get that data. Still on this one, there are 2 options. Number 1, what I'm going to do, I'm going to get my read command, which is read.csv. And then within here, I'm going to type in, I can either type in my path, or I can automatically now indicate I can now automatically indicate the data set that I want. Okay, in that particular case, there are 2 options, remember. I can use the read.csv and then I open the bracket. What I do, I paste in my path. Then to tell you that within this, when you reach this folder, but within this folder, there is a data set, lab2_data.csv. Then that's why I'm having, the moment I copy the path, then in the end, I indicate the data that I want there. So after that, I can run this. The moment I run, I look in the console, and then it shows me the data that I want to import. Okay, but like I mentioned earlier, sometimes you want to label your data set the moment it's being imported. You give it an object. Now I can say that, you know, I've already imported my data, but I want to create a name for it, an object for it, such that as I move on in the analysis, I only call that particular object. So for me, the object that I used, I named it diamond. So you can go back on the previous line on on the path that you've used. Instead of reading all that particular line, it will be too lengthy. You assign it a certain name, because you assign it a certain name such that you only call that particular name as you're doing the analysis. Personally, I called it diamond. So, okay, let me complete and then I'll redo again. And I say diamond. You can call it any name that you want. You can give it your name. You can say, you can call it Helen, you can call it Susan, anything that will enable you to remember that, you know, I was working on this particular data set. I chose the word diamond because the data set's about diamond. So I say, I'm going to assign it diamond. Remember how we assign in R, you either put an equal sign or a less dash, and then you say less or dash. The moment you do that, you run the line again. You click on that and then run. What is happening? Now, this time around in R, when you look in your environment, it shows you the object name diamond, okay? If you're seeing where my cursor is, and it also tells you we've got 100 observations and 7 variables, okay? If you don't want to go all through this, the moment you've set the working directorate, all you need to do, another simple option, you just use the read.csv command, and then in the bracket, in the inverted commas, this one here, in the inverted commas, you put in the name of the data set that you gave it, because you already have a working directorate. So it will just consider that and then bring the data automatically. I can get that, then I run it. The moment I run, when I look in my R console, it will show me the data. But I'm going to get back. And because I want to have a name for my data set, still I can call it any name that I want. I can say diamond, then I assign it, and then I put all my data set under the name called diamond. And the moment I run, all you need to see, look in your environment and see whether data has been imported successfully. Okay, let me go to the chart and ask. Can I do away with the CSV and only, yes, that is okay. Those are just options. Okay, please, let's go back to the work directory. Fine. Let me see, there are some people who have succeeded, but I'm going to redo it again. Okay. Okay, I'm going to repeat option 2. Again, let's go step by step. We need to import data. We finished with the one of Excel. I have no problem. The point is importing data. You can either import it in Excel or you can import it as a c.sv file. These are the two commonly data files that R uses. All right. When you check your data set, maybe let me share again the data set that we are using. Okay, and this is the data set that we are using. When you look at the top of your data set, kindly look at the top of your data set. How is it being saved? It has got lab2 underscore data.csv. Okay, this is the extension I'm considering. Like I mentioned earlier, for you to change the saving style within your Excel sheet, what you do, you go to File, okay? And then, for example, you can say Save As. Then they will ask you, where do you want to save that file in? I can pick any folder on my desktop, for example, and I consider that. What is important, it is this point here that I want you to get very well. Look at the Save As type. You can save the Excel sheet in many different ways, all right? When you come to the Save As type, when you click the drop-down box, it gives you different options on how you can save your data in Excel. Because we looked at it as in it's where our data is, but we want to import it in R, okay? First, we've used the common one, how the Excel sheet that we know. Most of the time, we use this particular extension. The dot, hope you're seeing where my blue line is. The extension of XLSX as an Excel worksheet. Or you can save it as a CSV. And that one is this one here, the comma delimited. I've already explained about the delimited in the sense that it gives you your data in a tabular form, in an Excel sheet form still. And it's also an easy way on how you can import your data. So this is how I saved that Excel to this particular format. You can either save it as a normal Excel sheet, or you can save it as a comma delimited, that is what I'm referring to as a .csv, that particular extension. The moment you have an Excel sheet, you can save it in many different types that you want, provided you know what you want to do. I'm not going to save again, but I just wanted to give an highlight on that. So the moment you click, maybe if you want it there, and the save as type, it will bring what you have selected. And the next thing that you'll do is to save. You'll put in the name, and that name will come with that particular extension. I'm not going to save again because I've already saved it like that. Let me ask in the chat, is the saving extension okay? All right. Okay, great. Okay, now let's go back. We want to see how to import data. I'm going to use now the simple method. How to import data that has been saved in the Excel sheet with an extension .csv, which now you already have. So I'm going to go back to my R Studio, the very simple method that we are going to use for today. I'm sharing my R Studio, please follow. Okay. Now, here we are. When you're using option 2, the first thing that is important is that you need to set a working directory. You need to tell R that the data that I want to use, it is contained in a certain folder. Like I mentioned earlier, I guess every one of you has a folder somewhere in your computer where these data sets are. So now let's set the working directory. How do we do that? It is very easy. Come to your RStudio, okay? Within your RStudio, please follow, go to session. We are setting a working directory. We are commanding R where our data is. You come to set working directory, and then you move and you come to choose directory. The moment you choose, it implies that you need to tell R where you're taking R to the folder where that data set is. Remember, I come to the desktop because my data is on the, I saved it on my desktop. I come to the desktop, I pick the folder where that data is, but my folder is embedded within this folder. So I click on it, but my data, it's within the module 1. I keep following the steps. I click on it once again. The moment you reach the folder where your data set is, you stop there. And then you come and click open, okay? You click open. If you click open, check in your R console and see, you will see a new line which has got set WD. Within the bracket, you see a path that you have used to set your working directory. So I want to ask in the chat, have you been able to set your working directory? Let's start from there. Please set your working directory for those who haven't, and then I will proceed. Okay. Yes. Okay. Ctrl+L. Okay, a good number has been able to do that. Great. Now I'm proceeding. Now remember, in case you want to save your codes very well, it is always good you put them in the RStudio in the R script, such that it is easy for you to always come back and rework on them. So what you can do, go in your R console, then copy the path, the set WD, copy it. Don't copy the prompt, just go and copy from the set WD, if you're seeing what I've highlighted, and then come and copy it in your R script such that you're able to save it, and you're able to save it such that, because within the R console, you won't be able to save, but you want to save our scripts. Just copy and bring it in the RStudio. The way you're seeing mine here, just copy from the R console, then bring it in the RStudio in your R script and save it there. Now, in case your set working D is successful, go at the end of the set working D directory and run it such that R gets to know that you've set a working directory under your script. Go and click run. The moment you click run, you will see the same thing again in the R console. So in the chat, I'm asking, have you been able to run the working directory? Okay, wonderful. Now, the next part is very simple. The next step is to use the read.csv command. It's what we are going to use to read our data set. What you can do, you can say read.csv. Okay, then in bracket you put, now go in the open brackets, put inverted commas and put the name of the data set within the folder that is saved as .csv. That data set is named as lab2 underscore data.csv and put it there. For example, I can type lab2 underscore data.csv. Okay. The moment you do that, go and run in your R Studio. If you're saying where I've put the cashier, then click run. The moment you run, you're going to see the data in your R console. Okay. Now the last step. The last step is let us create an object such that we are able to call our data. What name do you want to call your data? It's they call in R, we refer to it as an object. Personally, I said, I don't want to be calling it all this big name. Can I give it a name, for example, diamond, because I directly relate it with the data set. And I say, now I'm going to assign the whole of this data set that I've got in my console. I give it a name, diamond. You can give it any name that you want. And then I say, I assign it. Remember yesterday we learned about assigning, and then you copy this, what you have already. Or diamond is equal to something to be equivalent, that they are the same. So I put diamond is less dash the other one. And after doing that, you should be able, when you check in the environment, to see the name that the object you've given to that data set. I'm going to ask in the chat, have you been able to create a name or an object to your data set? What is in the Q&A? Okay. I'm going to just, because the moment that is done, now we are moving on to analysis. It implies that we've been able to import our data. Okay. Unless your data is imported successfully, you cannot do any analysis. That's why it is very, very important. Okay, I'm giving you 3 minutes. Please complete this part. Import your data from a CSV file. I'm giving you 3 minutes. Try it out again. The first step, set the working directory. Use the read.csv command. Within it, indicate the name of your data set. And then create an object or the name that you want to use for your data set. Personally, I use the name diamond. And when I look in the environment, I'm able to see that it's diamond with 100 variables and 100 observations and 7 variables. The moment you reach at that part, then we are good to go. We are good to start the analysis. If you saved your work on the desktop, like I said, if you're setting the working directorate, the moment you reach on desktop, stop there. Okay, and then R, the moment R will know that the Excel sheet is on your desktop. We are just creating a path, and then automatically you'll be able to pick it from there. The usual way as you navigate your computer, because you all know your computers very well. Okay. One minute. Please follow the steps. It is easy. Okay. Somebody is asking, I repeat the process for creating an object. An object is just a name that you want to call your data set. There are no steps involved there. And then you assign it to you assign it on the read.csv command, such that you use a simpler word, like, for example, I said diamond, and then it becomes easy for you as you're doing the analysis. Like I said, the word diamond, but you can change it to any name, put any name that you feel like. Name your data, something that will enable you to remember it very quickly. And then you assign it on your read.csv command. How do you name the data? Somebody's asking, can I use read.cs in bracket diamond? No, you cannot. The name that you put inside the read.csv, it is the name that you saved in your Excel sheet. The name that you used is what you put inside the read.csv. Remember the name of the data set that you what I sent it was labeled as lab2_data.csv. In case you change the name, then put that name. Only read.csv reads files from Excel that have got the CSV extension only. Does get WD? Yes. Okay. I want us to, that is right. Aman, that is right. Yes. It only reads CSV commands only. Can we use equal sign other than less or dash? Yes. It is the same thing. You can either say the diamond is equal or it is less minus. Now we are going to continue. Type continue if you're set, if you've already created an object for your data set, such that we proceed. I'm good to go. Okay. That is, I'm seeing a positive response. That is nice. So now let's proceed now. We've been able to import the data. Wonderful. Let's proceed. Remember, keep in mind the object or the name that you've labeled your data set. Okay. After importing your data using the read.csv, I labeled it. For my case, I used the name diamond. But in case you used another name, please, it's what we are going to use throughout. So keep it in mind that now you've labeled your data as diamond. It's a name that you're going to use. So it's what we are going to keep using as we continue. And that one I've already, okay, let's proceed. So sometimes if you want to have a feel of the name of your data set, what you can do, you can just type the name of the data set. For example, looking at what I sent you, I've already gone through this, please ignore that. Now just type the word diamond. The moment you type the name of the data set, depending on what you called it, on the next line you can enter and type diamond, such that you're able to view how your data looks like. The moment you type diamond, go to run. If you run, it will give you the nature of the data. It will give you your data set, how it looks like. Okay, I'm going to look at my console here. I want to scroll up. So the moment you type, if you look at my console, remember we run the commands in the RStudio, and then we execute them in the console. The moment you run diamond, this one here, you will see it will bring all your data set, everything contained within your data. So we had weight, quality, color, price, and so on. That was option 2. And I encourage you really to get it because it also becomes very easy as you're doing the analysis. Sometimes you might have a very big data set and you just want to have a quick look, maybe for the first 6 rows and see whether really they fit what you really imported. So in that particular case, we use the command head, and then within the command head, you type in the name of your data set. For my case, I called it diamond. And then you say diamond. After typing diamond, what you do, you run it. When you check after running it, you come to the R console, the R program. You're seeing your command, head, diamond. Then it will give you the first 6 rows. And you take a close look. Is it really how my data looks like? Maybe there was a mistake. Or in case you want to check the last 6 rows. Now, instead of using head, you use tail. Okay, I'm pausing to ask whether we're on the same page. Are we on the same page? Type okay if it's fine. Okay. All right. Remember, these are different commands that we are reporting. If you want to see a feel of your data set, and you don't want, sometimes you can have a data set that's got millions of observations, but at least you just want to have a feel look of how it looks like. You use the command head to give you the first 6 lines, or you can use tail, and then tail will give you the last 6. But most of the time we use, so when you type tail diamond, tail your data, the name of your data set, it will give you the last. You can, if you check the numbers, it has brought for you the 95th, 95, 96, up to 100, because in total we had 100 variables. The head gives you the first, the tail gives you the last 6. Okay. Sometimes it is important to understand the structure of your data set, which I explained earlier about the nature of your data set. For example, you want to check whether it is the numerical variables. So we need to check the different level of intervals. So in that case, we use a command str, which is structure. And then within structure, you type in the name of your data set. In my case, it is what? It is diamond. Now, after typing structure, you want to see what is entailed. How does your data set look like? So when you type structure, str, you run it, and then you come and look in the R console. What it tells you that it's a data frame, first of all. Data frame means it's a data set in simple terms, okay? With 100 variables, 100 observations and 7 variables. And then it also further tells you the different variables that you have and the nature of your variables. It is telling you that weight is numeric or numerical in nature, that price is an integer, they are numbers, then weight, length are also numbers, and just gives you just a little bit of how your data is, okay? But now, when you look at this setting here, R is giving you a character, CHR, because it is seeing wordings under quality and then color, whereby it has given you the first few within that particular column, it is showing you that premium, fair, very good, and then ideal. It's character it has given you, that they're just wordings. Now, as we move forward, we are going to instruct R that no, quality is not character, color is not a character. However, they are categorical variables. So for us to set them as categoricals, we are going to use a command which is as.factor, which now tells R that it's categorical in nature. Okay, I'm going back to the chart. Commas for somebody is asking that when do we use inverted commas? We stopped using inverted commas when we're importing the data. Now the next steps we are not. Yes, we are going there. Okay, some of the questions that you are asking, they are within the R script that that I'm using. So it is let's go step by step such that we all understand at the same time. Some of you are saying that you're lost and you're asking things that where we haven't yet reached. Mm. Now, there's a question that can head be used for Excel. But then you've already imported everything from Excel. Now, right now you are in R. You've already imported your data successfully, so leave the Excel parts aside. We are now in R, working with R. Okay, I'm asking again, can I proceed? Are we on the same page? Okay, I want to have you in mind that we are going to give you the recording, okay? And then you'll be able to see these particular steps, but try to follow as closely as you can. Okay. Somebody is saying that, can we try data with the first option? if you try data with the first option, it is very easy. Now, this time around, the variable, the object was given you, it was automatic. It was lab2 underscore data. So all you need to do is write the word head, then in bracket you put lab2 underscore data. It's the same thing. It is easy. Because when you check in your environment, if you're seeing my environment, I already have lab2 underscore data, which I use in the same option, and it's still the same. So now for you as an individual, instead of using the diamond, they labeled for you the direct name of the data set. Then keep using lab2 underscore data as your object name, which was automatically generated for you by R. So you shouldn't, please don't get confused. Can I continue? Type OK if it's fine. Okay. Okay, great. Don't let the name of the data set confuse you. If you prefer the first option, if it was the one that was easy for you, instead of diamond, now in that particular case, the object name, it is lab2 underscore data. You can put that and then check head in bracket lab2 underscore data. And so each time I mention the name or an object, make sure you refer to that one. Do not use diamond. Such that we move on the same page. Okay. Now I've checked the structure of the data set. Sometimes, for example, I've got this particular command, which is head. I remember I used head to see the first 6 rows. The moment you type head in bracket, the name that you've given, the name or the object that you've given your data set, it automatically gives you 6 first rows. But sometimes if you want to limit it, maybe for example to 3, that you don't want the whole 6, you can type head, in bracket you type diamond and then comma 3. This one, it will display the first 3 rows of your data frame, all of your data set. In case I do that, I run. And then instead of giving me 6 like before, it will give me 3. Okay. Now, sometimes you can check the class of the different variables that you're having. Still, we saw this when you typed the structure. It is the same thing. So you type class, the class command, and then in bracket, you put the name of your data set. Mine, I named it diamond. If you're using lab2 data, please put that as your data set. And that's what they're asking. And somebody was requesting for a break, but we only have 2 hours. Do you need a break or we continue? Participants, do you need a break or we continue? Yeah. Okay. Okay. No. Let's continue, and then we'll have, when we stop at 2, we'll break off, and then we get back on the link that Professor Susan sent you for support. We have got a support session from 2:30. So whoever is a little bit lost, please, you will join during the office hours, and we'll be able to clear all that seems to be lacking. Okay, I'm continuing. You can type class and then you run. When you now when you type class, then in bracket you put diamond. what it will tell you that the data set that you're considering is a data frame or a data set, such that you're very certain of what you're running. You can also get the general summary of your data set. Sometimes it is important. Remember, we are getting into the analysis. Now, what you do, you type summary diamond. The command is summary, and then you type the name of your data set. Summary in bracket, the name of your data set. So it gives you a feel on how your data set looks like. In case you use a different name, please use that. So what we do, you go and run. All your results are being displayed in the R console. So when you check the summary of your data set, of everything, all the variables that is entailed there, it will first start with your first variable, which was weight. Remember, it was numerical in nature. It will tell you the minimum, the first quartile, the median, the mean, the third, and then the maximum. On all numerical variables, the moment you ask for a summary, it will always give you that. The same applies to length, width, depth, and then price. However, when it comes to quality and color, it is still telling you that it's a character. It is, I mean, there are 100 of them, and the class is character. So, but remember, as we push ahead, we are going to tell R that no, it's not, it is a factor or categorical in nature. I'm proceeding. There are some other commands that you can run just to give you a feel on how your data looks like. For example, in case you want to know the number of rows that you're having, you can type the command n rows, n row, then inside the bracket, you put diamond or lab2 underscore data. Okay, so now whatever that we are using, it is now your data set, the name of your data, because that's why I told you it is important that you have to import your data rightly in R, and then the rest becomes smooth. So when you type n row bracket, all you need to do, put in the name of your data set to get the number of rows. The moment you click on run, it will show you that you've got 100 rows. You can do it for the number of columns. The command is ncol. Ncol, in bracket you put the name of your data set. It will give you the number of variables that you have. You do all this to check. When you're seeing, when you check in my console, because I typed ncol bracket and it is telling me argument X is missing, implying that I've not specified which I want the number of columns for what is the X. So the moment I dive it into and I indicate I want the number of columns for my data set, and then I run, it will, and then I run it, it will tell me that you've got 7 variables. You can go ahead and get the column names of your data set by the command call names, and then you enter. It will tell you that these are the names that you have, because sometimes you can forget. Each time maybe you want to run analysis on something and you've forgotten the name, so you can just type in call names, and then you see the different names you have. In this case, we don't have the variable, the row names. All it's going to do is just to display numbers. But in case you've named your rows, then it will give you the rows. So let's type this, the row names command. The row names, then in the bracket, you put the name of your data set, which is diamond or lab2 underscore. You run, and then, you run everything. And then plus sign. Okay. In case now I run, then it will bring me the different rows that I'm running from 1 to 100. I'm pausing, and then I ask if we're on the same page. Somebody's asking, where does one find the commands? Like I said earlier, in the different packages that we installed, they are developed on functionalities. There are different operations that we use. Okay. Now, but at least by the time you go to use a certain package, then and R is also very interesting. That is easy. You can go to Google and say, what command can I use in case I want to find the number of rows? What if I want to find the number of columns? What do I do? But the moment you get familiar with these things, like any other software, it becomes easy for you to like, okay, this is what I want. I'm gonna get the number of rows, or I want the dimension, or I want to see the column names. And still, when you check in the different R documents, you can see those commands. Why is it that my console comes with comments? Remember yesterday when I was explaining, I mentioned earlier that a hashtag, it is just to support you, to remind you of what this command means, but it is like, it's just a reminder. It is inactive. For example, in case, let's go back to the call names. Call names, then diamond. Okay, in case I just run that, I'll get the variable, I'll get the names within the variable names. So if I just put a hashtag or the comment, it is just a reminder, because we do different projects or analysis. And this one is just to help you that, okay, with this command, I wanted to display the number of rows. With this command, I wanted to display the number of columns. So please don't, that shouldn't scare you. You can put the comments or you can neglect them. Okay, let's proceed. Where? We'll answer it. Okay. When you look at the Excel that the R script that I sent, we've done most of the things. We've been able to import data into Excel using the different packages. So I'm not going to go through this again because we've learned how to use the read_Excel automatically. I was just rewriting them again. Now, the next objective that we are going to move on, sometimes you might have your data in R and you do some adjustments, which were not in the Excel sheet that you imported. It is interesting that you can now export back the R file that you've got to either as a text or as a CSV. And then from there, you can save it any way that you want. So now we've done with importing data, we've done the simple things that you can start with. Now let's move on to exporting data and proceed. In case you want to export, before you were importing, now you want to put the data back into either an Excel or a text. In case you want to do it in a text, I don't know whether some of you have seen data which is being saved in a text form. Text, I mean, it is with an extension, TXT extension. Now, in this particular case, we are going to use the command write.table. Why write.table? Because we still want to get our data into Excel when it is still in tabular form. So we are going to use write.table. The first thing that we put within the right dot table, it is the name of our data set. Okay, the name of our data set, which is diamond. However, in case you use a different name, please change it to that. And then the next thing that we put, you say comma. Now, what name do you, what type, the type of file that you want to export. Now you tell R that I want my data set to be exported as a TXT file. Okay. So now it is this particular command here, my file. I want the file, everything is going to be happening in the folder that you used. I want my file, the file extension I want to get. Yes, I did. Now I want to name it diamond.txt. Okay, that is the file name that I want to label it. But it all starts from here, depending on your file. If you used a different name, then it should be that name .txt. And then when you come here, I've already talked about the delimited files. The sept, it's a separator. It means that it's a separator. And it tells R that as you're exporting, I want my data to be tab delimited. I've already explained about what tab delimited is all about. My data should appear in a tabular form or in an Excel sheet. These are different arguments. By the way, in case you can also, like yesterday we looked at the help option. You can type help, and then in bracket you write dot table. The moment you write that, you come and click run. You check in the right hand bottom of the box. It will tell you, I mean, when do I use the right table? What is entailed? If we come here, I hope you're seeing my cursor, right.table, X is my data set, and then file, you have to put in the name that you want, and then you can put in these other arguments, but in case you don't want to use them, you leave them there. So I indicated the call names, everything within my command, it is on this part of the usage. If you're seeing what I've highlighted, because everything it's inbuilt in R. So it will give you the command, but you can seek further help on how you can use it. Okay, and then in case I say row names equal to true, this one just creates an extra column for the rows, and then the call names NA, you're telling R that please, I need to see the column names also attached in my diamond.txt file. Kindly run this command. The moment you run this command, if it is right, it will not bring an error. If there is a problem, it will bring you different readings. But you've not seen anything. So what you do, go into your folder where you stored, where you've been working from, and check, is there any file that is saved as diamond.txt, or the name of the name of your data set with an extension txt. Check in the folder. SEP is a separator. It's an argument. Type in the, you can type in help functions for R, and then it will support you. SEP is an argument that says to separate the different items. And the moment you add on this, it's equal to the, we have got quotes and then a T. There you're telling R that let my data set appear as a tab delimited, or you can look at it as in a tabular form, a tabular format in the Excel, like the way you see how the Excel sheets looks like. No. We just have commas in between. I want to ask in the chat, have you been able to see the text file in your folders? Great. Okay. Please check in the folder where you've been working from and see if you've seen the text file there. Hmm? Where are you supposed to check? The folder, it is where you've been working from, where you set your working directory. So go in that folder and look through. That text should be there. Okay. Can I proceed? Okay, great. The meaning of what? Really? Okay, let me repeat once again, such that we're on the same page. Sometimes the relevance, sometimes you can have data. And on your data within R, maybe looking at the diamond data set, during the analysis process, you've made certain adjustments. Okay, which adjustments were not in the Excel sheet that you imported earlier. So in this case, as you move on, you can be able now to import the current data set that you've used, where you've made certain changes, and then back to either you can save it as a text file or a CSV. We started with a text file because sometimes you can find data or save data as a text file, but still in R it can be done. So in that particular case, in case you want to learn more about write table, please go and use the help command, and then you read more about what it does. Okay, and then when I typed in help table, I come down here and it tells me under the write table, I've got the X, the argument, how it works. It has got the file. That is how I'm picking this to put into my file. All the things that I've put there, they're within here. Even I've got saved, I've got the raw names. I'm using, you can use the help command to alert you. That is where I picked these arguments from. Okay, file equal to the file. I put the name that I want to see in my folder, but it has to be related to your diamond data set, So use the name and say, let it have an extension of txt. I've mentioned about the separator argument, whereby for it is act as a separator, separate the different items. Because within when you open your text, it separates the different columns and you see how they look like. And then when I say that the call names equal to NA, what it does, it just adds an extra column to add the names of my variables. And after that, after finishing the command, all you need to do is to run it. The moment you run it, you're not going to see anything, but go in your folder you'll be able to see the text there. Why is it important? I said like before that some data can be stored in different ways. You can store your data as a text. You can store your data as an Excel. These are just different options that you can opt for. Now I'm moving on to the second option. What if you want to save it as a CSV? Okay. Still under the help command, when you proceed down, it gives you other arguments that you can use, write.s.csv. Do you want to see this kind of, now what you've changed? How do you want to see it? Do you want to see it as also as a CSV? Now in this particular case, we use the command write.csv. This is the command here. I put in my data set, the data set name. I put in the file argument. The data set name is what you called your data. And then the moment you write, the file gives you the structure or the nature of the data that you want it to look like. So this time you tell it that I want my data set to appear as a CSV. And all you need to do is to run that command. The moment you run it, still you go and check in the folder that you're using. You will see that now you've gotten another file that is diamond.csv. I'm going to go to the chat and inquire if all is okay. And then we move on to data manipulation. Okay. Okay. Remember, when we are setting the working directorate, okay, all my work that I'm doing for the training, it is stored under module R, if you saw it very well. So then are you able to see what I'm projecting? What do you see? No, just to ask if we understand. I want to share how the okay. I want to share how your text file will look like. If you check in the folder that you're working in, you should have your data set saved in this particular format. Because when you move on in the different analysis, some data you might get when it's stored as a diamond.txt. So this is how it will look like. Or as a CSV, check within your folder, it will still have that. It will have an extension of CSV. Okay, in case something is not clear, we'll continue with in the office hours. So I'm asking the chat, can I continue? Well, okay, now we are moving on to hope we are moving together. like we mentioned earlier, some of this work is going, you'll have a YouTube, and then you follow through step by step on your own pace. So now we are going to move to data manipulation. But let me first share my PowerPoints, and then we'll get back to R just briefly and see where we've reached. Okay, we've achieved this importing data. I've already explained about it. We've used the different methods on how to import data, and the second option, there we are good. You all have this material, so you can also use them on an individual basis. We've now seen how to use the read.tsv command. We've imported data. In case you have a Windows or a Mac and a Linux, please read through the PowerPoints. We've done this particular part of setting the working directorate. We've set the data set if we're importing data. Within the PowerPoints, we've got these particular commands, which you've gone through in R. You've agreed that now you know what they do, but also this can support you to get more information. And then I talked about the R comment, the slash. The slash shouldn't be a problem because it's just act as a reminder. You just write it besides the command, but R doesn't run it. It looks at it as inactive. It won't run it. So that part we have done. We've looked at the part of exporting data from R back to either the text or a CSV file. Okay, now there are some other important features that we can look at. Sometimes your environment can get clouded and you want to clean it. So in case you want to clean your environment, which has got your objects, what you saved, the command that we are going to use, it is remove rm, in bracket, it is list, which is equal to ls. The ls, it shows you the list of the objects that you have. So you're commanding R to remove. So I'll show you how to use that. In case you want to clean the console and you have a new one, all you need to do is type Ctrl plus Ctrl L, and then your console will be clean, and you'll see how you will have a clean one to work again. These ones I've already told you. The RM, it's just to remove or to delete the objects that you created within your working environment. And then the LS, this LS here, it just gives you the current list of objects that you have in your environment. Okay. Now, I want us to move to data manipulation, but let me check in the chat. Are we on the same page? Oh, okay. There is a question in the chat that says that what does it mean when you type in rows.names equal to true? That one implies that let the first row of my text file have the row names on it. If you go and check back, you will see that the row names were printed within our text file. Sorry? Somebody's asking, how do you open datasets in R? Okay, we open the dataset using the R script in the R studio. Then R executes the commands from the R studio. In case you want to use only R, then it implies that you won't be able to store your commands very well. How do you save? How do you save? When you we use the save icon Okay, I'll talk about that. I talked it about yesterday, but we can proceed and then see. Okay, let's move on to data manipulation. When we get back to R, I'll talk about how can we save. You know, we are going to do under data manipulation. We are going to see how do I create a new variable or record a new variable. Number two, in case I want to rename a column. Remember, our columns have got our variables. How do I do that? How do I subset columns of a data frame? How do I subset rows? How do I remove a column, all columns? Sometimes, you know, you might be working and then because, for example, maybe you have a certain variable, like in our data set, you've got length, width, and what, and then you want to create another variable, maybe like you want to have a sum of the two. How do you do that? That you're manipulating what you already have, and then you're doing it still in the same data set. Sometimes, if you can have it at the back of your mind, you can have a variable that is numerical in nature. And we know that variables that are numbers, we can convert them to categories. We can still do that. That is always data manipulation. And then later, we are going to see how do you have the different levels in R, and we do the descriptive analysis. This is what we're going to do in data manipulation. One option up to 6. Within the PowerPoint, I said you need to put the DPLY and the tidyverse packages to help us in the data manipulation. But good enough, we've already installed them and loaded them. Okay, I'm going to start with number 1, creating new variables. Remember, when you're creating a new variable, it's like you're going to assign, you're going to get a name that you want, and then you assign it. You assign with a less than dash, or you can use an equal sign. I want us to do this practically in R. Like I mentioned, because all these commands, we have them. So I'm going to do it in R, how you create the new variables. In case you want to record a new variable, how do you do it? If you want to rename columns, how do you get to that? If you want to subset, sometimes, for example, you might collect data in different regions of the country. Maybe you can say for example, in Uganda, you can do in the central, you can go collect data in the north, then you can collect data in the south. And then you're like, no, I only want to do data for only the central region. So you need to go to the big data set and only extract data for a particular region that you want to analyze. So that is subsetting. We're going to look at that. And then the different levels that I mentioned about before we move on to the descriptive. Okay, let's go back to RStudio. I'm stopping to share that. I'm sharing my RStudio. In case I want to clean my console because there's a lot of information, all I need to do is Control L, and then it will be clean. Can you please do the same for your such that now we move on to data manipulation? Just clean your console. Is it okay now? Can we proceed? Okay, fine. Now let's move on to data manipulation. Control, it is on your computer. Control, then L, it will be clean. Sorry? We are using the data set. Please note the ones that I sent on your different emails. Okay, we are starting with the first one. Let's learn, then we get a break at once, and then people with issues will be happy to help, so don't get discouraged. Now, the first thing we are going to do is to create a new variable, okay? But as you're creating a new variable, you can always remind yourself. Remember, we talked about the structure, the str command. You can run it again. The moment you run it, it will still bring you what you had before. Because why you need to understand your data set, you're not going to create a variable, a new variable. For example, when you're using a numerical variable and then a character, for example, the way they are mentioning it here. But remember, I told you we are going to change that to a factor. And what if I want to get the sum of length and width? I need to first understand whether do they both belong to the same class, because I saw what is showing me here that length and width, if you look here, they're all numerical in nature. They are numbers. So it implies that since the class is the same, if you look here, then I can what? I can be able to compare to them, but I can still confirm and check by using the command class. Okay, I can say class. Now, please note, in case you want to pick a variable from your data set, a single variable from your data set, remember you named your data set diamond. Okay, so you're telling R that go to the diamond data set and pick for me variable length. Go to the diamond data set and pick for me variable width. How do we do that? We use a $sign. So I want to find my class, although I've already seen the class in the structure. All I need to do is I type diamond, that go to the diamond data set, I put a $sign. The moment you put a $sign, R will automatically tell you the different variables that you have in your data set. What class do you want? Is it for weight? Is it for quality? Is it for color? Is it for price? And so on. And then you say that, no, I want to check for length. Then after that, at the end, you click run. It will tell you that it is numeric in nature. This NUM, it stands for numeric. Because you want to be very sure that in case you're going to manipulate, or if you want to do a sum or a mean or what, are these things the same? Are the classes the same? You can do the same for width. I know it is already numeric, but I just want to confirm. It will also tell you that it is numeric. So then I say, I want to create another, we started data manipulation, please be cautious. Now, Control Shift plus. Okay. Hope my screen is big now. Sorry about that. Let's proceed. So, since I know that length and width are numeric, are both numeric, so I can create a new variable called, for example, in case I want to sum them. For me to sum them, I can use a variable called, I can say, okay, I'm going to use an object. Remember what we said, an object is just a naming. Object in R is just the name that they are using. Because I want to sum these two columns, then I say, let me call it sum. I'm going to use a name sum. Okay, but you can use any other object. You can use any other name. But I want it to be part of my data set. So that's why I say, I start with my data set, diamond, the name that you used. Sorry, it is diamond. You have to be careful on that within my diamond, I want to create a new variable called sum. Why I'm putting the sum on my diamond? Such that I'm able to see this variable as part of the other variables. And the moment you do that, you say this one is equal to, you can either say equal to or less dash. And now you go and bring the separate columns. You say, I want diamond, then $sign, we said we want length, okay? That go in my data set diamond, get length, then the operations I add. Again, within the diamond data set, pick for me width. So in this particular case, what does this mean? I've created a new variable, which I'm naming sum, but I'm manipulating it from the already existing variables. And the moment I run this, if you run that, when you check in the R console, you don't see anything. But how do you see that this new variable has been created? Go to your environment where your diamond is. Check the variables, they have increased. Before they were 7, but since you've created a new variable, now they are 8. We can even view and see. How do you see that? You can just move your cursor where you're seeing the icon. Hope you're seeing where I'm pointing. Just click on it and then check your current data set now. It has got a sum variable on top of the rest that we have. Okay, I'm getting in the chat, I'm asking, have you gotten how to record a new variable? Type yes, if it is clear. Okay, great. Wonderful. Now let's go back. I can cancel that. Still, you can do the same thing. I went further to create another variable called mean. You know, when you're calculating mean of two, in case you've got two things, then it implies that you'll get the average. So you'll divide by 2. In case maybe you use like 3 variables, then you'll divide by 3. So I created another variable called mean. So now I wanted to get the mean of length when I've summed it with the diamond. Okay, please follow. It will help you to answer all the questions that you're posing. So I created another variable mean, and I got my 2 columns, the length and width. I divided by 2 because these are just operations that we all know. Then I say, now let me run again. Now my variables have increased now to 9 from 8. Okay, still you can view again. You can either type the view or just you come on your diamond within your history and you click on the icon that shows an Excel. If you click on it, you see that another variable mean has been created. So that is how you can manipulate most of your data. Please try that. Now, the last bit on that section of data manipulation. Sometimes you want to record another variable, which is still new. Remember I said, I'll give an example, that we can record a certain numerical variable into a categorical variable. For example, let's take up the marks of the students. You know, sometimes when you look at the marks of the students, they can range maybe from 0 to 100. And then you want to gauge and say that those who have got 0 to 50, I want to categorize them as fail. Then those who have 50 and above, I want all of them to be categorized as passed. Okay. So now I want to use that same knowledge to my data set and on price. Okay. Remember, I've got a variable price. And for me to get a summary, we've already seen how you can get a summary of the full data set. If you don't want to get a summary of a full data set and you want it to be for only a certain variable, you can type the command summary, and then in bracket, you tell it that go to my diamond data set and specifically pick for me price. Since it's numerical in nature, what you expect is to have the discrete summaries, the mean, the median, the marks, the first quartile, and so on. You see the results in your console, R console. Now, I want to categorize price. What I said, okay, do you know what I'm going to do? I'm going to use the if-else command to categorize my numerical variable. Why do I use? Members, we agreed earlier that a less dash is the same as equal sign. Me, I use a less or dash, but you can use an equal sign. It has no problem. It is the same thing when we looked at assignment. Okay, now I've seen that under my variable price, it has given me the minimum price, it has given me the median price, it has given me the mean price. Okay, now I want to categorize. Remember, I'm manipulating my data. Now I want to consider my threshold or the cutting point. I'm going to consider the mean. That those with a mean price that is less, I want R to categorize it as low. Those who are above the mean price, I want R to categorize it as high. So to keep my price variable, I'm going to create a new variable called price cut. The price cut variable, now that I know how to create a new variable, still I want it to be part of my data set, diamond. That's why I said diamond, $, the new variable that I want. And I say a less or equal, sorry, and I say less dash, and I use the if command, if or else. If it is this, let it be, if it is less than the mean, let it be low. If it is greater than the mean, let it be high. So in that case, if I'm to rewrite that, it will be if the if else command, they are built in R, if else, and then you open the brackets. So, but you have to tell R that this is what I want to categorize. So you go and say within my diamond data set, pick the price. And I've created a threshold that when it's greater than my mean, call it, when it is less than, call it low. When it's greater than this, call it high. And then after that, I run this and see what is going to happen. The moment I run that and I go back in my to view, you find that I've created now another column, price cut, depending on what I had earlier. Now, when the price of diamond was below my mean price, it named it low. When it was greater than the mean price, it named it high. Is it okay? Type continue if I proceed. Okay, somebody is saying that pause and we try. Okay, try. Wait, we try. Okay, please try it out. Sorry. Okay. I wanted to create a threshold. For example, the example I gave you about, in case you want to categorize your students, that some of them have failed, others have passed, but you only have the numerical figures like 50, 60, 80, and so on. And you want to say, okay, those who have below 50, I'm going to record them low. Those who have above 50, I'm going to record them as high. So it is the same thing that I'm doing here. And I'm using the if-else command. In case you want to have more details, remember when we say the help command in R, you can type help, then if-else. How does it work? Okay. Even before you complete, it will come and it will ask you that returns a value with the same shape as test, which is filled with elements selected from either yes or no, depending on the element of test. Is it true or false? Now the test that I've put is the condition. When they talk about the test is the condition. That what? Remember what we are trying to do here is to learn how you can manipulate data, okay? Depending on your interest. Personally, I might say that if the price of diamond is less than 4534, it is low. And then, so I tell the rate, if it's above, let it be high. But you can use the if and else command. You can even create more categories. Please consult the if else, or we can do more in the consultation hours. Okay, can I proceed? Tony Bale, Allah is case sensitive, yes. Please type yes if we're to continue, great. Yes, you always have to use a $sign if you're referring to your data set. That is an inbuilt character that you need to use. Okay, let's proceed. Now we are moving on. We've seen how to record a variable and also create a new variable. Let's see, what about renaming? Sometimes, for example, if you remember the call names that we had earlier, okay? If you have, I'll always type the structure back just of diamond, okay? To always give me a quick reminder. Within the structure, you're seeing that I've got quality. Within my data frame, my variables, look in the console, I've got weight, quality, color, and so on. Sometimes you want to rename your variable. Remember the variables that you're seeing, they're the ones that indicate the different columns, the data we are collected on these particular variables. Sometimes you may want to rename, okay? What if I want to rename weight, instead of having it weight, and I rename it weight in capital letters? In that particular case, I use a command, rename. Okay, I'm not going to run this library because we already loaded that. We use the rename, and then the rename command is what I'm using. Remember what I said, sometimes I may want to rename my columns to something else, especially to something that makes you quickly understand your data. Sometimes you collect the data, but when you name a certain variable, you quickly get lost and it doesn't catch your attention to exactly what it is all about. So what if you want to rename a certain column in your data? We use a rename command, okay? But now what I'm doing, I do not want to change to another data set. So what I do, I tell R that go in my diamond data set. You can say equals either, or you can use a less dash. You use the command rename. Rename, you have to put within the arguments, you have to tell it the data set. Where is it supposed to rename? So you tell it that within my data set diamond, and convert the weight that I have, rename it to be in capital letters. So the name that you want to rename is what you start with. So weight in capital letters to be equal to the what you want to change here. And when you run that, what is going to happen now? It is running that it is correct. So for you to check whether you've been successful, you can now call the call names again. Remember, we looked at the call command, then you run again. You will check that among the variables, now instead of weight to be in small letters, it has renamed it in capital letters. And you can do the renaming all the time in your analysis. Okay, are we on the same page? Have you tried to rename one variable in your data set? You can either rename maybe length, depth, and so on. Somebody's asking why diamond. Where is this? Okay. There is a question that is popping up, that why C low? C means concatenating in R, that concatenate those who are below my mean price, let them be categorized as low, and then those who are above the mean price, let them be categorized as high. So C is concatenating, putting together. Have you been able to rename? Can I be guided on how to install R? Yes, are you here? Okay. Use the function rename. So, and try to see if you can rename any of the variables. You can always do it when you're manipulating your data. No. Okay. Now let's proceed. On the next one, sometimes you want to subset. I talked about subsetting. The most commonly one used, for example, when I talked about what if you collect data from different regions and you only want to consider data from a certain region. Remember your data set is, remember your data set of diamond, you already have different variables. When we looked at something that I did not share about, which I haven't yet shared well about, in case, because for this command, I need to first mention it, that how can you tell R that this particular variable is a factor? Okay, so now what you do, you say from in my diamond data set, you put a $, quality okay? It's less or dash, or you can put an equal. You can type dot as factor. And then in bracket, you type quality. Okay, and then you can run that. Sorry, you're telling that diamond. A minute. Okay, just briefly on renaming, it is very easy. When you want to rename a variable, for example, I said you use the rename command. What you're seeing I've highlighted, okay? Rename. But remember, you are renaming in your data set. That's why I've started with the name of my data set, diamond. I want to do the renaming within my data set. So I said diamond, I'm telling R that within my data set diamond, rename a certain variable. So this, I put an assignment equal. Remember what we said about equal, it's the same as less or dash. I put my rename command that within the same data set, I want you to rename weight as capital with capital letters. And if you don't want to rename weight, you can rename quality, you can rename price, any variable within your data set. And the moment you run that, that is the only command you need on renaming. What have I done now? I'm going to clear this. So I'll put some other things. The moment you rename the diamond, and then you automatically, you can run the, in case you're running, it will automatically tell you that weight has been renamed to capital letters. That is the only thing you need on rename, there is nothing else. Now I'm going to move on something that is important. In case you've got a data set, okay? And it has, remember when we're running the, remember when we are running the structure, we saw that quality was character and price and, sorry, color was a character and quality was a character. But we need to tell R that no, these are variables that are categorical in nature. Okay, so for you to do that, we are going to use the command as a factor, or you can just put factor, anything, either you say as a factor or just factor. Both those commands will give you the same thing. But for you to command R that it is a factor, all you need to do that tell R, you type that in my diamond data set, okay, go and get the quality variable, like I'm adding it. And to label it as a factor, then you assign it that it's less dash as a factor. And in bracket, you type in diamond $quality. In that particular case, it will now, it is telling R that in the data set, quality is it is a categorical variable. So when you do that, you run, okay? And you do the same for color because it's also categorical in nature. Now for you to check that, to confirm whether it is okay now, okay? You type your string again and you type diamond. And then you run and check. Now you will see that now the names have changed. That for quality, it is telling you that they are factor, and we've got 5 levels. And then for color, it's a factor, and we've got 7 levels. Maybe as we continue, we are going to do descriptives as our data analysis 7. So just briefly, maybe you want to see that there is a function we call a command table. So you can type command table, and I'm going to make a recap shortly. The moment you run that, for you to prove that, then it will show you that, okay, since it's a factor now, it will tell you that the quality we had fair, these are the attributes somebody was asking about. The variable is quality with attributes fair, good, ideal, premium, and very good. So it is telling you the different numbers, that under fair we have 5, under good there are 8, under ideal there are 39, and so on. And so you command that color is also a factor. So I'm going in the chat to ask briefly, have you gotten what a factor is? A $ is used to select yes. Is a factor okay? Kindly type yes. All right. You use as a factor when you want to tell R that the variable that I'm working on is categorical in nature. Okay, now let's continue. Why I brought in that, because I wanted to use the subset command. Like, okay, looking at the DAM within my data set, looking at the quality, I only want to analyze other variables with only the diamonds that were fair. Remember, when you use the table here, we are saying that within the data set, the diamonds that had their quality as fair were only 5. So you're telling R that that is the only data set that I want. So for you to do that, we are going to use a command subset. Okay, the command is subset. Subset meaning that from the big one, I want to just pick a portion of it. But now, since you're picking a portion, then you're not going to call it diamond anymore. You're going to give it another name of that particular subset that you want to work with. For me, I called it diamond fair, just the names that are familiar. Then I come in the subset command and I tell it that within my data set, okay, within my data set, I only want within my data set, in the quality variable, only give me the diamonds that are fair. Remember, this quality is a variable which is within the diamond data set. But this time around, I'm telling you that only bring for me the data that has got only the diamonds that are fair. So when I run it, then when you look in your environment, I'm saying that I've gotten another list of an object, which is diamond fair. And because remember initially I saw there were 5, I can even view and see. So this is the only data set that I'm having with has only fair. If you look at the quality, now it is only giving me fair minus the rest. But I have all the other variables. Okay. I want to ask in the chat, have you gotten that? Please, if you joined late, we'll send you the YouTube. Okay. Somebody, that one? No, we can't. Looking at the commands, remember, this is an object, a name, a new name that I've created now for this new data set. I called it command fair. You can call it anything, but you have to ensure that when you say quality within this variable, I only want fair. So you can come and see how fair looks like, and it's what you put in the inverted commas. You put double equal signs. All right. I've given you the importance of subsetting. I've talked about, in case you want to call a certain column within our data set, we always use a $sign. The diamond $sign weight. Yes, it's the same as factor. Mm-hmm. Okay, now we've seen how to subset. We are going to move on to the fourth one, in case you want to remove certain columns in your data set. Okay, you can either create new data sets or you can remove in the same variable. In case you want to remove a certain column in your data set, they might be one or they might be more than one. We use a command, we still use subset, but this time around within the subset, what we are going to do, we put in another argument, select. Remember, I advise you, for you to check the arguments, always use the help document and then say, in case you want to use select, and then it will tell you what to do. When the moment you run, it will give you certain topics on how it has been applied, and it will support you. So that within my data set, okay, why I'm using subset, because I want to remove just a certain portion of it. I use the command select is equal to, look, I'm putting a -C. C, I said it is to concatenate, that putting together. In bracket of my C, I first put, if you look at that it is weight and quality. I'll put them together. That I'm going to delete out weight and then quality. I do not need them. Okay, and then, but remember, everything is within my argument, so I need to close the subset command. Okay, now when I run this, why it is giving me that it's not seeing the weight? Remember, I renamed my data set. So in this case, I can put the right name that I'm going to use to load my diamond again. Minor, it's to subtract, remove. Minus is removing. Okay. Okay, I want to use the same. Somebody saying that you can't hear me. Is that true? Can you hear me? Am I speaking to myself? Okay. Okay. Some of the things we're going to clear in the office hours for those who that will be available. Okay, let's proceed. We'll clear some issues in the office hours. when I put select equal to minus, I'm telling R the minus means that subtract or remove. So in that case, that within my diamond data set, okay, go and select weight and quality. For example, before I put a minus, that concatenates, meaning bringing together. Select for me weight and quality, but I don't want them there. Then I do what? I minus. The moment I minus, I run again. It implies that now my data set should not have the weight and quality there because I have what? I have removed them. When I run, when I check now my diamond data set, it has reduced from 7 to 5 because 2 variables have been removed. Okay, you can do the same for the rest. In case you want to keep the previous data set, you can create a new variable. In the second one, I just created a new variable, or sorry, a new name, a new object, which I named diamond 3, such that you maintain the previous data set. But since we are manipulating, so I'll leave that for you to check out. I've already talked about the level of measurements, when to use a factor. If your variables are categorical in nature, we've already done that particular bit. Now the remaining part is let's run the last one on descriptive statistics. I don't know if time can allow us to do that. We have 12 minutes remaining to 2, where we are going to get a break, but please bear with me. We run the analysis and then we'll get a break. Is it okay if I proceed? Just the remaining bit on the analysis? Okay. But let's start tomorrow. Okay. Let's continue. In case there's something that is not clear, we'll give a recap. But you know, when it comes to programming, it's always good to practice these things. If you don't practice, you'll forget them. Before we close, I sent an exercise, okay, with which has got it has a data set and then the description of those data, the variables. So whatever that we worked out today, it's what I want you to work out in that exercise that I sent. But let's proceed. Remember, I loaded my data set. Okay, let's run a few things before we close, which is diamond. Now I know how to, you know how to use string and then summary. These things you can run within the summary command. We saw how to get the mean, maximum, median, and so on. But still, you can use separate commands. For example, mean as a command in R, which is inbuilt, and then you say mean, I want the minimum of weight, and you say, go, I want the minimum, go in my data set diamond and get me the minimum of what? The minimum of weight. These are just commands that you can use. You can get the maximum, the mean, the standard deviation, and so on. Since you already have these particular scripts, I can just run them. You can say var diamond in my data set and then wait. I'm putting this semicolon because these are separate. I can join different commands on the same line. For example, in case I run the second one, in case I run this, in case I run my second line here, the one that has got range, so I expect to get 3 outputs: the range for weight, the variance, and then the median for weight. The semicolons, I'm just separating the commands that I have, but just on the same line. So when I run that, that's why when you look in the R console, it is giving you 3 outputs. The first one for the weight, the second one for the variance, and then the last one for the median. the standard error is still you can use the inbuilt-in function. I encourage you to use Google such that you know you can still feed in these particular things. We already saw what table. We only run a table for only categorical variables. When you use the command table, for it gives you the frequency, because remember with continuous variables, we run a summary statistics, but with categorical variables, we run frequencies and then percentages. So in this particular case, when I type table, which I've already showed you, go to my diamond data set, and then on the variable quality, and tell me what is entailed there. When I run, it's giving me just the numbers that when you come to your console, that my fair, they're 5, good, they're 8, ideal, they're 39, and so on. Okay, you can also create an object. For example, what I did, when I can still run color and see how it looks like, it will tell me that DE, it gives me the frequencies. Still on table, you can create an object and assign it. And you say, I want to use the call per as my object. And I say it is equal to what I already have, an assignment, such that I can quickly manipulate. So when I run that in R, I don't see the result. So it implies that now I need to run the object call, which I already have, then per. It will give me similar results that I had earlier, okay? Just because this time around, I've just assigned an object, which is called per, on the table. So it gives me the same answer. If I want to run percentages, I use a command, which is prop.table, okay? And I put in my object variable now, then I multiply by 100. So it gives us the percentages, and sometimes in case you want to round off, when you have many, for example, digits, in this particular case, since here we don't need to round off, then you don't need to use the round off command. We are moving on to data visualization. I don't know whether I should stop there if people are tired, and then we start from there tomorrow. Okay, now I'm going to stop here, okay? But kindly use the exercise that I sent you and try what we've worked out today. Import the exercise, try to do data manipulation because we are done with that part. And then tomorrow morning, we will start with data visualization for the first 30 minutes. And then Professor Susan will come in with experimental design, though she needs this particular basis that I'm giving you. Is it okay? Okay, we are having an office hour from 2:30. Kindly take a break. Those who are interested will be waiting for you. Please remember the assignment that I've given you. The more you practice, these things will become very easy. And even for those who would have tried something, they can share with us tomorrow before Prof starts the experimental designs. However, you need the basics with you. Thank you. We are going to share the web, the link, the YouTube link again for day 2, and try to find some time and go through it again. All right. Somebody's asking if the exercise will be submitted. The exercise will not be submitted, but it's good that you practice. It's for your benefit. And then at the end, we'll just have a true and false. maybe that will be multiple for people to choose, such that we see whether you've been able to learn something or not during the training. Okay, bye-bye. Have a great afternoon. See you at 2:30. Remember, we're going to be using a different link that Professor Susan shared. So we'll see you at 2:30. Bye-bye. Myself. Sorry, kindly check the chat for the support Zoom link at 2:30. We'll be around to give you support. Thank you. Rogers is saying he has not received any email.